So do you guys remember last time when we did the cross section? And I said, you're like a 3D printer doing all these slices. Remember this? Okay. So what we're going to do today are volumes of revolution. And I always joke when I'm talking about it, I'm like, revolution, but it just means that you're spinning around something. So remember how we had all the different shapes, rectangles, squares, semicircles, all those things? When you go around, all of your slices will be circles. So it's actually simpler than what we did last time because it's not any old shape. They're all going to be circles. What's the area of a circle? Pi r squared. So do you see that here? Pi r squared. Okay. They are all circles. If you go around a horizontal axis of revolution, that would be like the x-axis. So if it's this way, like the x-axis, then it's dx. So x-axis, dx. That make sense? If you have a vertical axis of revolution, and I was just trying to be silly about it, like the y-axis, then it's going to be dy. Does that make sense? X is at dx. If you go around y, it's dy. So they do sort of tell you, but you have to know the difference between vertical and horizontal. All right. So here we go. And you are going to have a little bit of an imagination here. Find the volume of the solid of revolution obtained by revolving, and then it just goes around in a circle like a merry-go-round. Bounded by. All right, let's graph this. Can you give me some points on square root of x? 0, 0. Good. What else? 1, 1. 4, 2. I like that. Oh, is anyone writing with pen? Don't. We're going to erase. No one's got a pen? Good. Okay, we're going to erase some things. All right, the x-axis, such as this, and the line x equals 4. So that's this. So this is the area that you end up with. And what I always recommend is erase all of the tails. Like erase everything that is outside of that shape so that you can focus on it better. So just erase everything that's outside of that. And you're going to have a little bit of an imagination. We're going to take that area and revolve it around or about the x-axis. Do you see that there? So I already know this is going to be a dx problem. If I'm revolving around the x-axis, it's going to be a dx problem. So what we're going to do is, I call it a ghost shape. You're going to reflect this over the x-axis. So draw yourself a ghost shape. And here's where your imagination has to come into play a little bit. You have to imagine this spinning around. Imagine it as three-dimensional. If you turn it this way, it would be like a cereal bowl that you could not put any cereal in because it is solid the whole way through. Do you get what I'm saying? You're taking this and spinning it around. It's circular. It's I don't have a piece of paper that will make this pop up out of the page for you. I'm sorry. You're going to have to imagine it. This shape is coming up out of the paper and spinning around, and you're ending up with a shape like this. So what I want you to do, and we're going to find the volume of that three-dimensional object. I want you to do is set it up blank. It's going to be pi r squared dx. And it is still either upper minus lower or right minus left. Okay, so let me use a different color and I'll try and get you to see it in here. This is your radius, and it's going to be upper minus lower. The upper graph is this one, which is which one? Yeah, square root of x. Minus the lower one is the axis, which would just be 0. If you didn't want to write the 0, fine. I'm just trying to illustrate for you that it's still upper minus lower. Are you seeing? It's very much me pointing at it. I kind of can't force you to see it. Now, your boundaries need to be x values because this is x and that's dx. So what are your boundaries going to be? 0 to 4. Now, does that seem reasonable to work out by hand, or should I reach for a calculator? Because it's either reasonable or not reasonable. Reasonable, because if you ignore that 0 there, you have square root of x squared, which would actually just be x. And then it's not complicated at all, so let's just go ahead and do that. Pi is just kind of following you around until you get to the end of the problem. All right, what is your antiderivative of just plain x? Yep, 1/2 x squared such that 0 to 4, it's upper minus lower, but you can ignore the 0 because it's just going to be nothing. And so if you plug in 4, what do you end up with? 8 pi. Good job. Let's try it again. Find the volume of the solid generated by revolving. Revolution. All right. Region bounded by. What would this look like? Yeah, your wiggle. All right, you're going to have 0, 0, 1, 1, -1, -1. And it looks linear, but it's not. Like, just make it wiggle. It's going to look like this. Again, bearing in mind, we're going to erase here. So don't write it as hard as you can. All right, the y-axis, so that's this right here. And the line y equals 3. Now that's a horizontal line, so that's going to be right here. So this is your area. This is your shape. Kind of looks like half of a Hershey Kiss. And then what I suggest you do is erase all the tails. Like, erase everything that's outside of that shape so you can focus just on this. Now, what does it say we're revolving about or around? I hate that they say about. It should be around. Y-axis. So I immediately know this is going to be a dy problem. And so I want to right away go ahead and rearrange my equations so that they're backwards. So how would I get x by itself for this? Yeah, cube root. So x equals cube root of y. Again, I have found for some reason that if you circle that, it helps. And now I'm going to go ahead and draw my ghost shape on the other side, which is going to look like this. It's sort of similar to the one we just did above. But you have to imagine this shape coming up out of the paper and spinning around. So again, it's kind of like a top or like a pointed cone sort of thing, or like a Hershey Kiss. Imagine you took a Hershey Kiss and turned it upside down. Circular. You need to imagine it as being circular. So when you go to set this up, do it blank. It's pi r squared dy, because you'll forget the squared or you'll forget the pi if you don't set it up blank. Boundaries are going to be y values, so that would be where to where? Yep, 0 to 3. And this time it's going to be right minus left for your radius. So again, just watch me point to this. This is your right graph, which is which one? Cube root of y, good. This is your left graph. And since it's the axis, it is 0. Good. So I'm actually just going to write cube root of y if that's okay. Or you can write minus 0 if you want. It's right minus left. Now, does that seem reasonable? There's going to be a fraction, but you're going to be okay. But we can work this out by hand. So pi integral 0 to 3. Now, what's your fraction exponent for a cube root? It is a third, but ours is going to be 2/3 because of the squared. Good job. You guys came with me on that. I'm basically having us do this one by hand so you can practice your fractions more than anything else. All right, antiderivative. You have to add 1 to the power, which would be what? Yeah, 5/3. In front of that, 3/5 and a pi, such that 0 to 3. And then we're just going to plug 3 into that. I'll be really honest. I don't know what 3 to the power 5/3 is, so it's going to get left right like that. They're going to look at a graph if you draw one. So it literally does not matter. They won't even read it. This one, I made a part A and B so we can copy our shape over. All right, so let's go ahead and draw this. This is going to be a parabola. It's upside down, and it's moved up 4. So go up 4, put a point. If you plug in 1, you're going to get 3. If you plug in 2, you're going to get 0. So like this. And then it says the x-axis and the y-axis. So this is going to be your shape here. And then if you could just go ahead and copy that right here. I did that on purpose so we could just reuse our same work. I think I might do one more of these by hand, and then we'll just kind of put them in the calculator for the sake of time. Because I have to do 2 lessons today. Like we have more to get through. So I think we'll do one more by hand and then we'll kind of just put them in the calculator. Because I think you guys are okay with your antiderivatives. So this one, it says we're going to spin about the x-axis. That means it's a dx problem. So if you want to draw your ghost shape down here below the x-axis, it's going to be like this. You want to imagine what that looks like. Again, it's circular. If you turn it this way, it would kind of be like a pitcher's mound. Do you get what I'm saying? Like, can you imagine that? Or does anyone else have an idea of what that would sort of look like? I think of like a pitcher's mound. Like it's round, but it's sort of like mounded up. It's circular. Okay, you're all telling. Pi r squared dx. Set it up blank so you don't forget the pi or the squared. And your boundaries need to be x values since it's a dx. So look at your x-axis. That would be where to where? 0 to 2. And then this is your radius. So it is upper minus lower. What is the upper graph? Yeah, the parabola of the 4 minus x squared. The lower graph is 0. So I'm not going to bother writing that one. It's just going to be the 4 minus x squared. I'm going to do this one by hand as well, more for the algebra than anything else. Before I can do the antiderivative, you have to do 4 minus x squared squared. So if you can hold that in your mind, that's totally cool. If you, bless you, if you want to write it twice, that's totally cool. But I basically want to do this one just so we can get through the algebra. If you multiply these together, 4 times 4, 16. You get minus 4x squared and minus 4x squared. So that's minus 8x squared. And then negative x squared times negative x squared will be positive x to the 4th. And then we're going to do the antiderivative, and then we'll do our boundaries. So I'm going to leave pi out front. I'm actually just going to bracket this off so the pi can just sit out there. Antiderivative for 16. 16x minus 8/3 x cubed, perfect, plus 1/5 x to the 5th. Such that 0 to 2. And again, basically you can just plug in 2, because if you plug in 0, those are all just going to go to zeros. Like for the sake of time, could you plug in 2 and we're all okay? Let's just move forward. Okay. Now this one, we're going to spin it around the y-axis. So this is going to be a dy problem. You're going to draw your ghost shape over here. So go ahead and set it up blank. Pi r squared dy. Again, do it blank every time. You will miss the squared or the pi or something if you don't just set it up blank. Pi r squared, they're all circles. So you need these to be y values. And so it'll be from where to where? Yep, 0 to 4. And now I need to go back and rearrange the equation so that it's backwards. So just in the margin here, what would we do to this to start to get x by itself? You have to rearrange it. Yep. Minus the 4. Before I square root, you have to divide by a negative, which you can either write negative y plus 4, or you can just reverse them if you want. And that's what you said. I just had to get everybody else there. To divide by the negative, and then we're going to square root. So when I go to put this into my integral, it's going to be right graph which is that one we just looked at, minus left graph, which is when it's the axis, it's really nice because it's zero. You're probably like, hey, what if it's not zero? I've got you. These last two, it's not going to be zero. Okay. So that is our square root of 4 minus y. Now that would be reasonable to do by hand because what's going to happen there? Yeah, they're going to cancel. But again, for the sake of time today, we did 3 of them by hand. I'm going to just put this in the calculator. All right, so your job when I type this in the calculator is to watch and make sure I don't mess it up. I'm actually just going to write 4 minus y dy. 3 decimal points. So 25 points. We'll say 133 because on delta math they round. I like to truncate, but on delta math they round. So we'll say 0.133. Cool. A couple more and then I'll give you a break. This feels like it's going. You guys are really tired. It feels like it's okay. Are you? I don't know. Guess we'll find out when I give you a test. All right. Find the volume of the solid generated by revolution. X equals y squared. So that's going to be a parabola, except instead of right side up, it's going to be sideways. Good. So just draw yourself a regular old sideways parabola. It's all the exact same points, just sideways. I can never draw it sideways, though. I don't have to turn the paper. It still doesn't look great, but whatever. All right, and then the line x equals 4. So that's this vertical line here at 4. So we're going to have this be our shape that we're looking at. I'm going to erase all my tails. Now, the reason this one's not going to be 0 is, read the question. What are we revolving around? Because it's not the axis anymore. The line x equals 4. So what my suggestion is, do you see that there? This is the line of our revolution. All right. Dot that in. That is what you're spinning around. Now, when you go around the x-axis, it's dx. When you go around the y-axis, it's dy. When we move the axis, everybody loses their mind. So watch me point to this. It is like we took the y-axis and just scooched it over. Do you see that? Okay, so it's going to be dy. That's how you tell. It's like I just took the y-axis and moved it over 4 units. So here's your ghost shape. And we're spinning around like this. Use your imagination and pretend that's solid the whole way through. What does it look like? What kind of a 3-dimensional object did we get? Football. That's what I was hoping you would say. Or like an egg. Easter's coming up. You know the little chocolate eggs that are solid the whole way through? Like one of them. Okay, I'm glad you all said football. You're seeing it. You have an imagination. Good job. All right, so let's go and set it up blank. Pi r squared dy. So your boundaries need to be y values. Good. Do you see how she got that? Is everybody there? -2 to 2. And then inside of here, it's going to be right minus left. All the ones we've done so far, one of them was 0. That's not the case now. So watch me point to this. This is the right graph, and this is the left graph. So what is the right one? 4 minus the left one, which good is y squared. Nice. That went well. Good job, guys. This is your radius here. Is right minus left. So I'm going to go ahead and just slam that in the calculator. Again, your job is to make sure I don't mess up. I can actually just sort of alter this a little bit. There, did I do that right? -2 to 2, 4 minus y squared dy, 107.233. One more. Find the volume of the solid generated by revolution. What is this going to look like? Upside down parabola. So just go ahead and draw your regular old upside down parabola. It's not like stretched or shrunk or anything, so all your points are still the same. All right, and then the line y equals -1, which is this. So you get this like tiny little shape in here. I'm actually erasing most of what I wrote. I just have that tiny little shape. And what is our axis of revolution? Because it's not the axis anymore. It got moved. Yet y equals -1. So if you dot that in, good. Do you see how it's like you took the x-axis and just scooched it down a unit? So it's going to be dx. Have you guys also noticed how as soon as I realize which one it is, I write that? It's a good idea. So here's your little ghost shape. This one's kind of small. Let me zoom in. And you have to imagine it spinning around like that. So what does that look like three-dimensionally? It's practically a sphere, isn't it? Like not quite, but like almost. Like like those little, oh, what were they? I just had a thought. You know, lifesavers, but they had the holes from them. Do you know what I'm talking about? Those little candies. They were like practically spheres, but they weren't. Maybe I'm crazy. It was like just, or like a donut hole. Do you know what I'm saying? Like, yeah, like lifesavers, but it was the center of them. I feel like that was a thing. Anyway, yeah, I'm thinking of like a little candy. Yeah, but it was like practically a sphere, but not really. Anyway, I'm just trying to get you to use your imagination. All right, pi r squared dx. Oh, I swear that was a thing. I like have a memory of it. What? Maybe. Oh, like a gusher, sort of. Like almost a sphere, but not. All right, so your boundaries need to be x values. That would be where to where? Yep. -1 to 1. And then kind of watch me point to this. It's going to be upper graph minus lower graph. So which one is the upper? Yeah, the parabola, so that's your -x², minus the lower one, which is -1. It is +1. I'm going to write it that way so that everyone can see the subtraction. It's upper minus lower. When I go to type it in the calculator, I'm just going to write +1. But is everyone, are we good? It's -1. Okay, cool. Actually, that's a problem, but you guys are just handling this. So, all right, I in, what are we, -1 to 1, parentheses, -x² +1. Well, I'm going to need another parenthesis. I'm going to give lots of hugs here. Squared. dx. There we go. 3 point, oh, this is super teensy tiny. 3.351.